In this video, I want to talk about circuits with dependent sources and provide an example of how you can use Kirchhoff's voltage law and Kirchhoff's current law to solve such a circuits. So let's just take a look at this circuit to the right. We have this 500 volt independent voltage source with polarity positive and negative as specified here. We have a 5 ohm resistor, we have a 20 ohm resistor, and finally we have a current controlled current source. So this current controlled current source has the equation 5 multiplied by I delta. So the current that this current source is providing is 5 times I delta. So what is I delta? So based on the specifications of the problem, it is specified that I delta is the current that goes through this 5 ohm resistor in this direction. So what we need to find here is that we want to find the value for VO, basically the voltage across this 20 ohm resistor. So we can have several observations here. First is that if we know the value for the current that goes through this 20 ohm resistor, we can use Ohm's law to find the voltage across it too. So remember, Ohm's law was stating that the voltage across any resistor equals the resistor multiplied by the current that goes through the resistor. So for this specific resistor, VO is going to be 20 multiplied by IO. So that means that out of the two variables that are unknown for this resistor, we only need to use one of them. So here we chose to use I0 to find it. The other observation that we have is that once we know I delta, we also know the current supplied by the dependent source, because the dependent source current is 5 times I delta. So if we know I delta, we basically know 5 times I delta too. And finally, the last observation is that the current in the 500 volt source, this one, is I delta. Because if you remember from KCL, when we have elements that are connected in series, the current that goes through them is the same. So since this node is common between these two elements and there is no other connection, other element connected other than these two elements to this node, they are basically in series. So I delta is the current that goes through this independent source too, because again, nodes do not provide any current, also they don't absorb any current. So now that we know these, let's just come up with the equations that we want to have. So the first equation that I want to write here is based on the Kirchhoff's current law, or KVL. And to do that, I use this closed path. So I start, you can say, from node C and go around the path, and for each one of them I write the voltage for each one of the elements. So if I do this, I first enter this 500 volt voltage source from the negative side. So as I said, I use it with negative sign. Then I get to this resistor from Ohm's law, I know that the voltage across it is going to be its current multiplied by 5, the value for the resistor. So it's going to be 5 I delta. So even though I didn't specify the polarity here, since I'm following the passive sign convention, this is equivalent to having the polarity in this form, right? The current goes from in the direction of the voltage drop for the resistors. And now the last part, the last element in this closed loop is this 20 ohm resistor, which has the current I0 and the value for the resistance is 20. So the voltage across it is going to be 20 multiplied by I0 based on the Ohm's law. And the summation, the algebraic summation of all of these voltages is going to be 0. So these two equations are equivalent. I only took this negative 500 to the other side of the equation. So 500 equals 5 I delta plus 20 I0. So that is the equation that I want to write based on the KVL. So in this equation, as you can see, we don't know the value for I delta. Also, we don't know the value for I0. So because of that, I will write an extra equation based on the Kirchhoff's current law, or KCL, for node B. You can write it for node C as well, and it doesn't make any difference. For node A, it doesn't matter, it doesn't produce any useful information. It only says that the current that goes through the 500 volt independent voltage source and the current that goes through this 5 ohm resistor is the same, right? So we already assumed that to write this equation. So let's just write the KCL for this node. If you remember, we said that anytime we have a current that comes to that leaves the node, we consider it with the positive sign, and anytime a current comes into the node, we consider it with a negative sign. So let's just write the KCL for this node. We have negative I0 plus I delta from the left side plus 5 I delta from the right side. So 5 I delta from the right side equals 0. You could write it the other way around too. So you could have considered I0 with a positive sign. So you assume that anytime a current leaves the node, you consider it with a positive sign. And I think I said it that way, but I put the sign in reverse, right? But as long as you are consistent, it doesn't matter. So if I write it that way, this is what I have. And these two equations are completely equivalent. So based on this equation, if I rearrange this, I see that I0 becomes I delta plus 5 I delta. So if I take these two to the right hand side, I get this simpler, more straightforward equation, which says that I0 equals 6 I delta. So now we have two equations. So let me just quickly write this down. So 5 I delta plus 20 I0 equals 500. And then I have I write it like this: 6 I delta minus I0 equals 0. So these are the two equations that we want to solve. So the easiest way to solve this is to say I0 equals 6 I delta, and then replace this in the above equation: 5 I delta plus 20 multiplied by 6 I delta equals 500. So if I do this, that means 125 I delta equals 500, which makes I delta to be 4 amps. When I delta is 4 amps, since I0 is 6 I delta, that means that I0 equals 24 amps. So we have I delta to be 4 amps, I0 to be 24 amps. So the final conclusion, the value that we were looking for, VO or V0, right? I use these interchangeably, right? So VO equals 20 I0 based on Ohm's law, which is going to be 480 volts. So this is an example of how we can solve circuits that have dependent sources. So in this video, you learn how we can solve circuits with dependent sources. More examples will be provided as additional materials, and I highly suggest you go through all of them to master the concept.